Welcome to Engage Math, Lesson 20, Problem 3. We are factoring by grouping in this situation because we have 4 terms. So the way that we know to group the first 3 terms together is because the first 3 terms are going to form what's called a perfect square trinomial, which you probably recognize from some of the previous lessons or earlier in this lesson. So I'm going to zoom in. Sorry, that was a quick zoom in. And just to make sure you can see, but I have the two factoring patterns written out at the top so that you can see that m squared plus 6m plus 9 is going to factor as m plus 3, the quantity squared. Now, if you wanted to do it the long way, you could say, oh, what adds to 6 and multiplies to 9, and that would be 3 and 3. And so you could write it out as m plus 3 and m plus 3. But I'd like you to get to the point where you can look at that, know it's a perfect square trinomial, and simply write it as m plus 3, the quantity squared. Okay, that's the first 3 terms. Now, I'm going to kind of underline in a different color this term. So for that, I'm just going to write the minus 25n squared. Now you might recognize, even though it's really tough to see, this is now the difference of 2 squares. In other words, we can now factor by taking the square root of the first term, so m plus 3, and then I'm going to just kind of show this part in blue to show you the minus 5n, and then we're back to the red with the square root of the first term, which is m plus 3, and then we're going to this time say plus the square root of 25n squared, which is 5n. And this is the completely factored form. Okay, so it started as a perfect square trinomial, and then we did the difference of 2 squares. Okay, let's go to B, and I'm going to zoom in a little bit so you can see this really clearly. I think we'll do the same thing, just so you can kind of see by the colors. The first one is going to be y minus 5, the quantity squared, and then in blue, I'm just going to write minus z squared. Okay, so it's once again the difference of 2 squares, so it's going to be y minus 5, and then we're going to take the square root of the z squared, which is minus z. And then for the next parentheses, we're going to once again say y minus 5, the square root of the first term. But this time we're going to do the positive version, and we're going to say plus z. So the difference of 2 squares, just to remind you, is the a squared. I'm just going to write it out in case it's helpful. A squared minus b squared factors as a minus b. A minus b and a plus b, but that's what we used in this problem. Okay, so it had a couple different things. This is a tough concept, but hopefully that makes sense. This is our final answer right here. Okay, we have 4 light bulb problems coming up. I'm going to zoom in on each one individually. I won't color code it as a light bulb problem. I'm just going to roll right through it and see if you have some questions. Okay, the first one is going to be 7x minus 3, the quantity squared, minus 81k squared. 81k squared. Okay, now we have 7x minus 3 minus 9k times 7x minus 3 plus 9k. Because it's this, then after we factored it as a perfect square trinomial, then it becomes the difference of 2 squares. Okay, let's go to D. For D, I'm going to first group the first 3 together again. So it's going to be 10a plus 1, the quantity squared, and then it's minus b to the 4th. Okay, so the first time we're going to say 10a plus 1 minus b squared, and then the second time we're going to have 10a plus 1 plus b squared. And by the way, it doesn't matter which of these 2 parentheses you write first. I tend to put the minus first and the plus second, but it doesn't matter. I think even in the back page of your workbook, on the reference sheet, it actually has the plus first. Doesn't matter. So I could have done it with plus b squared here and minus b squared there. Same thing. Okay, 2 other tough ones. Let's go to E. And for E, we're going to once again take these 3 together. This is a really tough problem because first thing we have to do with factoring is always take out the GCF, the greatest common factor. There's no greatest common factor for all 4 terms, but there is for the first three. So what I'm going to do, since I know we're grouping 3 and 3, is I'm first going to write this with the x squared factored out. Okay, and this time I think I will color code it a little bit to make sure you can see what's what. Okay, so now the trinomial in that parentheses is a perfect square trinomial. So I can now write it as x minus 2, the quantity squared, and then I still have the minus 36. Okay, now it's the difference of two squares again. So the square root of the first term would be x times x minus 2. That's the square root of this. That's kind of the red. And then I'm going to have minus 6. And then the second time, I'm going to have, again, x times x minus 2. And this time, I'm going to have plus 6. Okay, but we can simplify a little bit. This is a really tough problem, but stay with me. It's a great problem, actually. Okay, so it's x squared minus 2x minus 6. And then the second time, we're going to get x squared. I'm just distributing that x minus 2x. Sorry, there should have been an extra parentheses right here that I somehow didn't write, but I think you see it now. X squared minus 2x plus 6. Okay, so once you look at that, you may think like, all right, am I done? And the reason you are in this case is there's not two numbers that add to -2 and multiply to -6. So this is all you can do. You're going to leave your answer in that form. And that's everything for right now. Okay, let's go to F now. This is the last one. And for F, we have, let's see here. Wow, we have 1, 2, 3, 4, 5, 6 terms. So it says group the first three together. So this is going to be a tough one. I'm going to kind of highlight again with the colors. Whoops, let's just change that a little bit. We're going to highlight those three in red, and let's do these in blue. It's going to be a little tricky, but you can do it. Okay, the first three, not so bad. It's perfect square trinomial. It factors as x plus 5, the quantity squared. Okay, now let's go to the blue. Before I try and factor that, I find it really hard to kind of picture what the signs are going to be unless we write it this way. I'm going to put a minus sign outside of a parentheses, and all I'm going to do right now is change the signs on these terms, and I want to make sure you see why this is exactly the same problem. So if you think of distributing that negative through, you'll see you'll get negative y squared plus 12ky minus 36k squared. Exactly what the original problem is. I just pulled the minus sign out as a greatest common factor from those three terms. Okay, next step. We're going to rewrite x plus 5, the quantity squared. Nothing else we can do with that. But here's the tricky part. This is also a perfect square trinomial. So we can say y minus 6 y minus 6k, the quantity squared. The reason I know it's a perfect square trinomial is the square root of the first term, the square of the first term, y squared, and this times the square root of the last term, 6k, gives us 6ky, and that doubled is 12ky. That's why I know it's a perfect square trinomial. Okay, so now one more step, maybe even more than one. Let's even kind of see how this goes, but I think there's just one more step. So now we're going to take the square root of the x plus 5. Let's change that color just to help you see it. So the square root of x plus 5, the quantity squared, is x plus 5. And then we're going to have minus, and I'm going to just kind of put down here, it's minus the y minus 6k. So it's minus the square root of the second term squared. Okay, and that's one big parentheses. Then I have another parentheses, and I once again have x plus 5, and this time I have plus the quantity y minus 6k. Okay, and this time we don't really need the parentheses around the y minus 6k because we're not distributing a negative like we did in the very first parentheses. All right, so now I think I'm just going to show you the final answer and kind of color code it in black. So what we have is x plus 5 minus y plus 6k, because that negative is going to distribute through. And the second parentheses is going to be x plus 5 plus y minus 6k. And that is all we can do. So hopefully that is all making sense. It's a really tough problem, but thanks for hanging in there with us at Engage Math today. I'm going to go back to the original screen in case you wanted to look at all the answers together, and we'll see you next time.